My name is Kiran Pandey, roll number 50, currently in MSc second semester, and to submit the virtual lab experiment to the head of department. And the title on this experiment is to verify an interpretations of truth table for NOT gate. The purpose of a logic gate are used to make the decision so that the electrical output only turn on when correct logic sequence has been applied. Each logic gate has a name that helps to describe how different input will determine the possible output. An abstract on this experiment is logic gates are the basic building blocks of the digital hardwares. The operation of basic logic NOT gate is explained over here. High active and the low active input signal are defined and illustrated in this section. These are the keywords used in this experiment. These are the transistor, switch, battery, and the block. And this is the principle of logic gate. Each type of gate has one or more input and just only one output. The principle of operation is that the circuit operates on just two voltage level, logic 0 and the logic 1. The logic 0 means low, and this is the logic 1 is preferred as high. This is the theory over the NOT gate. A NOT gate is a logic gate that inverts the digital input signal. For this reason, a NOT gate is sometimes called as inverters. A NOT gate always has a high logic 1 output when its input is low, that is the logic 0, and vice versa. This is the logical symbol for the NOT gate is over here, and truth table listed the output of the particular logic circuit for all the possible combination of the input is over here. The truth table for a NOT gate can be represented as in this way. This is the input. If we have input is 1 and the corresponding output is 0, this is the our truth table. It means just it inverts the output. This sorry, this inputs invert the input is output. This is just complement of the input section. If we have a input is 1 and the corresponding output is 0, and this is the NOT gate transistor circuit diagram, and here is a 5 volt VCC supply over here and connected to the resistors, and this is the point A, and this is the simple bipolar transistors, and this is the output where we measures the corresponding input. In above circuit diagram, we examine the high input voltage applied over 5 volts. This is the 5 volt applied over here, and this is the point 0.5 volt is going in this section, and the corresponding output is this is the 0. In this condition, the transistor triggered enough base potential to make it on. As soon as the transistor becomes on, the supply voltage is plus 5 volt at the terminal B will get the path to earth through the resistor R. At one condition, the transistor behaves short circuit ideally, and hence entire supply voltage will drop across the resistor R, and the no voltage will appear at Y. This means this in this output section, and hence the output of the inverter or NOT gate will be 0. In actual fact, there will be some voltage drop across the collector and emitter even at one condition of the transistor. And this is the off condition of the transistors. This is the transistor base potential voltage is about the 0 degree because it has grounded over here point A, and the supply voltage will not get any path and to the earth, and entire supply voltage will appear at the output terminal of the NOT gate or high logical 1 when input terminal is low or logical 0. These are the advantages of the virtual lab experiment. Virtual lab experiment can provide the equivalence experiences to the physical labs and even offer experiment that could never be offered in the college laboratory. And the virtual lab helps to teacher and student have saved the time and effort because they did not require any adhere to certain times of the enter the lab or move one place to the another places. And this is the basic hypothetical lab that provide the comfort in changing the input and the parameter that used in the experiment without worrying about any dangerous effect of these changes. And the conclusion over this NOT gate is when the logic 1 is applied to one of NOT gate, then output becomes 0. When input is on, that is red, and the output LED becomes off, green, vice versa. Thus the Boolean expression can be realized using the NOT gate. I This is the acknowledgement, and I would like to acknowledge this virtual lab to the dean, head, all the faculties, PhD research scholars, senior laboratory supporting staff, and administrative staff, and all my classmates. These are the references which was used in this theory sections, and we are just going on the appendix of this circuit. This is the basic NOT gate IC, and in this section the point 14 is always VCC and the point 7 is always grounded, and these are the point 1 to 3 to 14. From the point 1 and 2, we insert the NOT gate and take the output from here. This is denoting by the Q1. And similarly, this is the 3 and 4, this is Q2, 5 and 6, this is Q3, and so on. And what is the explain over appendix B? Explain the what is the inverters. An inverter is a logic gate whose output is inverse or complement of its input, and explain what are the basic logic elements. The basic logic elements are NOT gate, AND gate, OR gate, exclusive OR gate, NOR gate, etc. And the flip flop. And this is the basic function of NOT gate is often called as the inverter. It is a nice logic gate to start with because it has only single input with the simple behavior. A NOT gate performs the logical negation on its input. In other words, if the input is true, then the output will be false. And this is the another most interesting buffer gate. This is the generalization of the NOT gate. Simply, it has both input and output section always equals. Output and input always equal. Buffer are used to increase the propagation delay circuit by driving the large capacitive load. And we are going in the simulation process with this section over here. This is the our NOT gate experiment performed on a kit by using the simulation process. Here I consider the transistor as a NOT gate. This is the basic NPN transistor. This is the bulb. This is the battery is disconnected over here, and this is switch 1 and switch 2. In this experiment, we first connect this battery. This is the battery is connected over here, and switch 1 is on. This is switch 1 is on, the bulb is glow, that means the bulb is on. And this is the green path. This is the green path uh, follow through the current. This is the current flow path. Green path representing the current flow path, and this is the red path. This In this path the current does not flow. If we on the switch 2, and this is the switch is off. If we off the switch 2, this is on, bulb is on. And if we on the switch 2, bulb is off, and the green signal is provide the current flow path. And we check the hours, verify the not get truth tables. And this is the verification of the truth table for the not get. And let's check the truth table. If we have input is 1 and the corresponding output is 0, This is check over here. This is the correct statement. This is the correct. And next one is if we check the input is 0 and output is 1 and the correct. This is also correct. Thank you.